Welcome back to Chapter 4. This is 4.6, Formalizing Relations and Function. So a relation is a pairing of numbers in one set, or a collection of coordinates. Now our domain here is all x and x values in a relation. Our range is all y values in a relation. Alright, so for our domain here, we list all of the x values. So we have 4.2, 7, 5, and 4.2. We do not have to list the 4.2 twice, but we do have to list them in order from smallest to largest. For the range, we have 1.5, 2.2, 4.8, and 0. Again, from smallest to largest is how we list these as well. Now we do have to figure out if the relation is a function, which remember means that each x value needs a unique y value. I should not have one x value going to more than one y value. But for this one, I have 4.2 going to both 1.5 and 0, so that means this is not a function. Alright, looking at the next one, we still need a domain for this one as well. So remember, domain is x values from smallest to largest. So I have -1, -2, 4, and 7, which are coincidentally already in order for us. And then our range is the y values, also in order. We have -7, -4, 2, and 1. Putting them in order from smallest to largest. We start with the -7, we end with the 1. Each of my x values has a unique y value, so yes, this is a function. Alright, we're using the vertical line test to figure out if the next two relations are functions, which means we have to do some graphing. So we have 4, 2. We have 1, 2. We have 0, 1. We have -2, 2, and we have 3, 3. Now the vertical line test means I can draw a vertical line through any point of my function and only ever intersect one time, or one of the dots. So no matter where I draw my red line here, I'm only ever intersecting one dot, so this is a function. Alright, number 4, let's do some graphing here. We have 0, 2. We have 1, -1, we have -1, 4, we've got 0, -3, and we have 2, 1. Alright, if I draw my vertical line through the y-axis here, I'm intersecting 2 points, so that means this is not a function. Moving right along, we're going to do some word problems here. So, for our first problem, we have a function t of x equals 65x that represents the number of words t of x that Rachel can type in minutes. How many words can she type in 7 minutes? That means we're plugging in 7 for x, and we get 455 words in 7 minutes. Alright, number 6, we gotta find a reasonable domain and range. So we have Lauren, who has 4 rolls of ribbon to make party favors. Each roll can be used to make 30 favors. The function f of r equals 30r represents the number of favors f of r that can be made with our rules. What are a reasonable domain and range? Okay, so the domain, she has 4 rows, so at most she can use 4 rows, but she could use anywhere between 0 and 4 rows, so that's going to be our domain. Our range, we have to figure out how many ribbons she can make depending on how many rolls she uses. So if she uses 0 rolls, we plug in the 0, she makes 0 ribbons. If she uses 4 rolls, we plug in the 4, she makes 120 ribbons. So our range is from 0 to 120. Alright. Next, we're evaluating compound functions. So we have f of 4 minus g of 3. So let's figure out what f of 4 is. 2 times 4, that gets us 8. G of 3, we plug the 3 in for x in the g of x function. 3 to the third is 27 minus 4 is 23. Then we got to subtract those two, so f of 4 was 8. So 8 minus g of 3, which is 23. And that is negative 15. And that is it for this video.